All right, here we are with another This Week in Cassandra, Planet Cassandra. I'm John Haddad. Today we have Tyler Hobbs of DataStax. He's a committer to open source Cassandra. We also have Aaron Morton of The Last Pickle, also a committer, I believe.
Yeah, from the old days.
Yeah, pretty exciting. Old school committer. It's great. We have some good stuff here today. We're going to be talking about the new Cassandra releases, and we're also going to be taking a really big look at the new storage engine in 3.0. So first, let's talk a little bit about what's happened this week. Big news is we're looking at two Cassandra releases, 3.0.4 and 3.4. 3.04 is a bug fix release, so it's going to have a bunch of stuff fixed in the 3.0 line. Good stuff if you're already running 3.0 in production. And on 3.4, that's our new features. In our TikTok release cycle, if the last number is odd, then it's bug fixes. If it's even, then we're looking at new features. So it's a feature release. Let's take a look at that. So Tyler, what would you say is the new interesting stuff out in 3.4?
In 3.4 or 3.04?
Well, the new stuff is in 3.4.
Right. Yeah, so I think by far the biggest new feature in 3.4 is the SASE indexes. Those are contributed, one of the main people was Pavel, developer at Apple, and Cassandra PMC member. Mm-hmm. These are, a huge upgrade from what we have in Cassandra and older versions of Cassandra for secondary indexes. Basically, in previous versions of Cassandra, the secondary index works as kind of a hidden second table that for each indexed value, there's a partition that stores primary keys of the index table for every row that matches that indexed value. So it's basically just a primary key that we then use to go do another lookup on the base table, and that comes with there's a lot of inefficiencies in that, and it's very limited in terms of what operations it can support. It's basically just sort of a hash index of sorts. So the SASE indexes. Maybe John, you can talk a little bit about this, about how they work, but they really, they provide a lot more efficient support for some new operators.
Mm-hmm. Yeah. So the interesting contrast to the existing secondary index implementation with SASE is with SASE, effectively you have an index written per SS table. So whenever an SS table is written to disk, you also get a B plus tree written, which is a really efficient storage format for doing database lookups, for range lookups. It's optimized for disk seeks. It normally can get problematic if you have a lot of updates and deletes. That's why you see issues with relational databases under insert and delete and update heavy workloads. But in our case, because Cassandra has immutable data files, you can actually have perfect B plus trees written to disk, and then they're never touched again. So from a performance standpoint, they don't slow down over time. You just generate a new one during the compaction process whenever you write a new SS table. So they support prefixes. You can do there's a like clause that you can add to it. So the things that people kind of are used to in relational databases where they want to do range queries and they're not 100% sure of the queries that they're going to do ahead of time, this will support a lot more flexibility. And it's really cool. And I've played with this a bunch, and I wrote a blog post. It's on rustyrazorblade.com. It's very, very cool stuff. It was really fun to actually use a like clause and see results come back. The only thing that you have to keep in mind is because they're B plus trees, they're memory mapped files. You're definitely going to want to run this in systems where you have more free available RAM. Not so much an issue if you're in somewhere like Amazon where you can fire up a machine. You've got, so let's say, 60 gigs of RAM. It's okay if 20 gigs of that is indexes. Totally fine.
Yeah, I think the other thing to keep in mind is they still have some of the same caveats as the existing secondary indexes, right? They still don't make sense for indexing all types of data. You don't want to index an email address or some other unique value with these, because the fan out when you query still has to happen. It still has to touch essentially every node in the cluster to build a query response. So while they do have some cool new things, you still have to treat them in a lot of ways like the existing secondary indexes.
Yep. Yeah, the scatter gather aspect is definitely going to be always problematic. And I think in this case, for your example, like emails, you would probably want to use the materialized view feature that got introduced in 3.0.
Absolutely.
Yeah. So the interesting thing here is that you can say that as views, while they may be a little bit slower at write time, are going to give you a huge performance boost at read time. So if you have like equality searches and you have like reasonably high cardinality where you're not, you don't want to have like, let's say a materialized view on like people's ages with 1 billion people in your database, because it's just not practical. If it's something like email where you can get a super fast lookup, it's going to be better than secondary indexes. So it's cool. I think we've got multiple tools that can solve different problems different ways. Each one has certain trade-offs, but I think as we get used to them, we're going to see some really good recommendations come out and kind of advice. So I'm pretty excited about both those things. And then the other thing that I wanted to just kind of briefly touch on was the return of the SS table. I mean, it used to be called SS table to JSON. Now we have SS table dump. You guys have used that more than I have. What's you excited?
Yeah, this is critical to ever explaining Cassandra to anyone. Like every time I've explained the write path and the immutable files and how the read path merges those things together, the ability to say, hey, let's insert a row, flush to disk, insert a row, flush to disk. Look, I've got 2 copies there. You can see now that this data is on disk in multiple places, and you can now see what the read path does. That's always been really important. I used this a couple of weeks ago, the new SS table dump, when I was looking into what happens when we drop a column in CQL, and it just works, and it does a really good job of outputting it, and it's really useful if you're trying to understand things. I wouldn't use it as a way to back up your data or export it. I think there's much better ways to do that. But as a what's going on here, I've been doing this for a few years now, and a couple of times we've had to get someone's SS table, pull it out, convert it to JSON, take that tiny little piece out that somehow made things crash back in the day, and then put the SS table back. So every now and again, they're useful for that. I don't think it's such a cause now. It's mostly as a learning tool. It's invaluable.
Yeah, and I guess it's good to point out that SS table dump doesn't have sort of the inverse operation of loading it back in, right? We don't have a JSON to SS table equivalent anymore. But yeah, I agree with Aaron. It can be really instructive just for looking at how data is stored out on disk, from a teaching perspective, but also for doing support and operations. That really can help you understand. So somebody recently on the mailing list wondered why a partition was so large, even though it had relatively little data in it. And just by dumping the SS table, they were able to see that it had 10,000 tombstones that they didn't know existed there. So just being able to see that sort of information can be really helpful in debugging different types of problems.
Yep. Yeah. Very good stuff. So we were talking a little bit about, we've got 3.4 out. Looking forward, since I don't really get the opportunity to have committers, in the room very often, or in the virtual room. Tyler, you were telling me a little bit about some of the stuff that you're working on going forward for the future versions of Cassandra. What do you got for me?
The future is bright for Cassandra. Off the top of my head, there's one of the things that's is in progress right now is non-frozen UDTs. So we're looking at being able to store those split across multiple cells. So right now we essentially force them to be serialized into a single cell with the frozen keyword. So we're making that optional now, so that they'll be stored across multiple cells, and that allows you to update each field in a UDT separately, or individually, and it can also allow you to optimize the read path. If you're only selecting a single field from the UDT, you don't have to deserialize the entire thing. So that's kind of a fun one. I'd say by far the biggest change that I'm working on right now is part of the work to switch Cassandra from this CETA model right now, the staged event-driven architecture, to a thread per core model. So this will have really big performance implications for Cassandra. Really, what we're looking to do is eliminate a lot of the overhead that we see from context switches. Right now, Cassandra uses tons of different threads, split across a lot of thread pools, so it's constantly doing context switches, which is expensive in terms of CPU caches. We also have to use a lot of suboptimal data structures to be able to handle that multi-threaded concurrency. So eventually we'll be able to isolate this data to, say, a single token range is handled by a single thread, and that'll allow us to use some lock-free data structures, things like that can really help out the throughput and performance of Cassandra. So it's a massive undertaking, and we're looking to do it bit by bit. Right now, we're focusing just on the read and write paths, but I think by 3.6 or 3.8, we might start seeing some of the first parts of this be released into the wild, and we'll see how it works in real life.
Nice.
So yeah. Yeah, it's a big project.
Yeah, it sounds like a lot of rewrite, but yeah, you definitely, the overhead of context switches and locking everywhere. If you ever like follow a program with strace, you can just see it's just mutexes all over the place, and getting rid of that and making it more optimized definitely improve performance overall. So that I'm actually very excited for that. So we've got 3.4, pretty cool release. We got some really interesting stuff coming in the future. Let's back it up a little bit and talk about the 3.0 storage engine. So Aaron, you just wrote a blog post on the 3.0 storage engine. You can find the link in This Week in Cassandra blog post. It's very detailed. This is something that, Aaron, I love your attention to detail and stuff like this. I saw a talk that you gave maybe 3 years ago when I was first learning Cassandra on the write path and the read path and just how Cassandra works. And it's good that you didn't get lazy and give me something less than that. So I appreciate that. So yeah, I don't know. What can you tell us about the new format? Like, what are some reasons why this thing exists?
Well, if you think back when Cassandra started, so 6 years ago, the storage engine really hadn't changed a lot in those 5 or 6 years up until this release late last year. And if you think about how the API has changed, CQL3, CQL had a little bit of a bumpy start. CQL2 seemed to be just MIA. And CQL3 was just a huge change. And it's gone on in ways that maybe the original guys thought about, but the extensibility that's added into the platform is huge. Mm-hmm. And it's all been done on some nasty hacks on the existing storage engine. And the biggest one, I think, was that the existing storage engine had no concept of a CQL row. They were something that was kind of hacked on top of the internal storage engine row, which came to be known as a partition. So just that as a basic fundamental thing to say, hey, we now know what the data model is. Let's efficiently store that in the storage engine. It's led to a bunch of improvements that, again, we're probably not going to see all of the impact for a while. There's a really great post that Sylvain did when this first came out that explained just the impact on how it can reduce the on-disk size. And there's a lot of stuff in that blog post I point to around that of understanding things like hey, every cell that we put on disk has a timestamp. What about if we record that from an epoch of every cell that's in that SS table, rather than the Unix epoch? So if you've got a time series data model, for example, when we flush the disk, we're going to record something that says, right, the lowest timestamp we have here is 12 o'clock. So if I want to record a timestamp that's 12:01, all I need to record is that it's 60 seconds or 6,000 milliseconds, whatever, higher than that 12 o'clock timestamp. All that type of stuff means, and some variable int encoding means that on disk it's a lot more efficient. And if you have a look at that post, and there's plenty of links in there to go to the code, you can really get a feel for the idea that now we know what's actually going on disk. And if you look around at some of the old examples of how to explain CQL3, it used to be, all right, here's CQL3, now I better explain how it stores it in the storage engine. And that's really complicated because, look, there's this cell here on the storage engine that doesn't have a name and doesn't have a value. That's important. Like, just trust us on that thing. We were talking earlier, and Tyler was saying we don't repeat all of your clustering keys. The values of those used to be repeated for every non-primary key cell in that row. And that doesn't happen anymore. All that information is stored once. And it's so much more efficient on disk and really sets the groundwork for the next couple of years. It's really exciting.
Yeah, one of the cool things is that, because we had so much redundant information in older Cassandra versions, compression made a really big difference. It would take care of a lot of those issues, or at least mitigate them. But yeah, if you look at that blog post by Sylvan that Aaron mentioned, you can see the new storage format is so efficient that in a lot of cases it's smaller than the compressed SS tables from the previous version, even without compression. So one of the things that people can look at doing now is actually dropping compression from their SS tables to save a bit of CPU. It might be a win for them in newer versions.
Mm-hmm. Yeah, and I've even spoke to people who are gone back to basically Cobalt column names because they're scared of all of those wasted bytes on disk by having long column names, and it's a terrible thing. So hopefully, if we can prevent that, that's a good thing.
Yep. Well, one of the things is it's nice to just have the schema even encoded separately, right? Like that used to be just a separate ticket, right? It was like, no, it's totally ridiculous. Like the fact that your column, the fact that the name of your field can like dramatically increase the size of your SS tables is just absolutely nuts. And I mean that alone is a huge win. And then you talk about not repeating certain values like TTLs or timestamps or encoding them as a delta from the beginning of timestamp that you saw for that particular row. I mean, the savings are huge. I think I remember seeing, like, for certain size tables, you can see like a 10-fold reduction, right? Like that's absolutely crazy to be able to see an optimization like that. Like, when do you ever get something that gets 10 times better? Never. So
when you, go ahead, Tyler.
I was going to say, I mean, it depends on the workload, but especially if you're storing a lot of small values, especially like a single row per partition or even a wide row kind of format. If you don't have large values that you're storing, you'll see a massive reduction in size on disk with the 3.0 format.
Yep.
Yeah, I think all the way down to the individual cell storage. Whereas previously we'd have the timestamp at every cell. If all the cells in the row have the same timestamp, we just have it at the row level, and that simple understanding of knowing that these things are all collated, all these things are together, has saves space and saves reading off disk. Down to things like, I can't remember if this was already in the 2.0 engine, but we know when different data types are fixed and when they're variable width. And booleans are just encoded as a byte. And then if there's 3 booleans together, it's just 3 bytes in a row. And we know when we go to read that off disk, what's in that, what actual columns are in that row, their order, and so fixed width things can be read very efficiently off disk. And then the complex cells, which are the complex. So complex cells are things that deal with our things like UDTs and collection types. And previously these were frozen, as Tyler was talking about earlier on. Now they're non-frozen, and they're so much more extensible and will support the type of feature that Tyler's talking about of non-freezing UDTs, so that you take your idea of here's my column that's defined in my table, it's really a list or a UDT or whatever it is, that when it gets to the storage engine now explodes into a bill of materials type approach where it's like, okay, here's my column, it's a cell, yeah, my cell is made up of other cells. Each of these cells is then encoded as a cell inside of that one cell and is then individually addressable. That type of feature just wasn't around previously. Tyler, you were talking earlier about a really interesting point, which was the dealing with dense versus sparse tables and optimizations for those.
Yeah, one of the kind of the cool things that Sylvan designed into the new 3.0 storage format is that we'll switch to using a different storage format based on whether the set of columns that are actually used is sparse or dense. So, for example, if you only have 10 columns in your table and you pretty much always write to all of them, we're going to use this dense format that's optimized for that. On the other hand, if you have say 1,000 columns defined for your table, and each row only normally has 2 or 3 columns actually set, we switch to a different format that's specifically optimized for that as well. Sort of on both ends of the use cases, we've got a more efficient format than we had in 2.0. So it's kind of nice to just to optimize for these different ways that people use Cassandra.
Yeah, that was really interesting as I was reading through the code on that. It's in the encoded cells. If it's mostly missing, or if they're mostly there, then we encode it one way. If they're mostly missing, then we'll go a different approach. And similar, the surprising bit, they're supporting there for if your number of clustering keys is above, I believe it's 32, then they're encoded in a different way than if it's less than 32. They're put into chunks of 32 clustering keys and encoded. So really a lot of attention to detail of dealing with things that nowadays we might laugh at, but later on we might be like, wow, that's really great. It handles those 128 keys in my clustering index. That's great.
Yeah, he definitely went and prepared for like every single scenario imaginable.
Yeah, there's a lot of features in there that are kind of, we don't really utilize them now, but they set a nice foundation for a lot of features that we're interested in building soon. So hopefully this format will help us to kind of grow and support new features efficiently without resorting so much to the old hacks that we kind of had to build on top of things like in the 2.0 storage engine.
What are some features that this will enable?
Some of the things that can work really well with the new storage format are things like being able to push filtering predicates to replicas. That was something that the old storage format just wouldn't let us do. Now that I'm on the spot, I can't think of them all, but
I think there's a really like macro level thing in here, which is the entire on disk format is now pluggable. So previously there was one way we wrote to disk, and that was it. It's now there's an interface, well, there's a factory, an interface, a whole mechanism in there to say, hey, let's try a different on disk format. Like, whoop-de-doo, let's go encode this stuff as Parquet, whatever, as an experiment. And that's a nice big top-level extensibility point that probably didn't exist. And I think all of the extra knowledge that's there will lead us to be able to improve performance over time. We know what cells are encoded into each SS table. right, that's some useful information we could go and do things with. And the extensibility around the encoding of cells onto disk will mean that I think like the UDTs and all those types of things will become, I think you'll probably see some more activity in that field and more complex predicates that can get pushed down to disk.
Absolutely, that's a good point. Like the the non-frozen UDTs, those are so much easier to do with the new storage engine. There was a ticket that got talked about on here a couple of weeks ago, optimizing the number of disk seeks that we do based on SS table metadata. If you have like a limit 1 on your query, that's something that would have been really insane to do with the old storage engine, but is easier now. Doing per partition limits is something else that's we have the plumbing for now. There really is a lot of stuff. I kind of froze up earlier, but it's a long list of things we can.
My one nitpick is that the key space and the table name have been removed from the file name for the SS table, and we think that's probably for Windows compatibility. But that's my one nitpick I found in the whole thing so far.
Nice. All right, guys. Well, this has been pretty fun. I'm pretty sure that people are going to want to hear more about the SS table format, learn more about it. I definitely recommend, as I said before, reading Aaron's blog. It's awesome. It's in the blog post that accompanies this video on Planet Cassandra, so definitely check that out. Get into it, and there's lots of really good stuff is coming up, and that has just been released. So it's pretty fun week. So yeah, I want to thank you, Tyler and Aaron, for on, and yeah, I think we can wrap this one up. Oh wait, Aaron.
So I was just going to say, I'm in San Francisco. The TLP is going on the road next week, so Nate's going to be talking at the Cassandra Day in Atlanta on Thursday next week, and then I'm going to be talking in San Francisco at the San Francisco meetup on Monday week about CQL3 and Storage Engine 3, and then talking down in South Bay meetup about how to back up Cassandra.
Nice. All right. Tyler, anything you want to say?
Nope, nothing at all.
All right. Thanks, guys.
Thank you.
Thanks, everyone.